and to discuss some of the findings with all the participants, and hopefully it will be a beneficial and productive discussion event for this webinar. Hence, this is important with regards to three main objectives. To showcase research findings from short-term study on overall tropical forest ecosystem productivity. They will be discussing different sites within the capacity, within their research sites, within the time frame they have been given to work on their research. And also the aim of this webinar is also to gather feedback and information exchanges between among all these research communities in regards to specific NEP components that involves heterotrophic respiration from soil, root decomposition, fine root dynamics in forest soil, and so on. And lastly, to address research needs and knowledge gaps of NEP study in tropical forests in the future. Perhaps I would like to introduce a little bit about NEP. It started off since 1990s when the Japanese were having research in one of the most famous forests in Malaysia, that's Paso Forest Research. And it started off all these working on primary productivity, ecosystem exchanges, atmospheric exchanges, and slowly these advances are coming in. And today we will hear three of the speakers talking about their advances, what they have been doing. This will be an exciting time for us to listen and understand the development into such a topic. Today we have three prominent speakers. I hope everyone will enjoy the talk today. Number one, the first speaker would be Dr. Pongtep Hanpatanakit. He is from the Faculty of Environmental Culture and Ecotourism in the Srinakari, sorry, I have to make this right. Srinakarin Wirot University, Bangkok, Thailand. He will be our first speaker. Our second speaker would be Mr. Afzanizam Muda from Forest Research Institute of Malaysia. And our third and final speaker would be Dr. Jayani Vijayanathan also from Forest Research Institute Malaysia. Let me introduce the first speaker. Before I introduce the first speaker, let me introduce some of the rules in the house. Please, everyone, we have about perhaps 100 or more than 100 participants this morning. Please, everyone, mute your microphone so it's easier for the speakers to speak. And also we will, after this, each speaker will be given 25 minutes to speak. And after the 25 minutes talk, we will have one or two burning, important, critical questions. You can submit your questions online on the chat room provided in the Zoom. I'm sure everyone understands how to do that. Please just type and provide questions rather than chatting. Thank you very much. And also towards the end of all the talks, we will have a photo session where we encourage everyone to turn on their video camera so we can take a group photo online. And hopefully this will be a good remembrance for us for this IFS-SEARCA international webinar. Without further much ado, I would like to introduce the first speaker, Mr. Dr. Pongtep Hanpatanakit. He is a lecturer now, associate professor lecturer in Srinakarin Wirot University in Thailand. His academic qualification, he holds a Bachelor of Science in Biotechnology, where he first started in Mae Falun University in Chiang Rai province. Then he continued and obtained his master's, MSc, Masters of Science, and PhD in Environmental Technology in the University of Technology, Thonburi, also in Thailand. His field of specialization is very much into ecosystem processes involving carbon dynamics and greenhouse gases production and emission, especially carbon dioxide, N2O, and methane. Now, he has a lot of working experience. He has a vast working experience in lectures in Srinakarin Wirot University. And also he has been working as a research assistant in Thailand, working on LULUCF, or the Land Use Change and Forestry Agricultural Sector Project with JG-SEE King Mongkut University. He has various research experience, also publishing various topics, mainly in dry dipterocarp forests, and of course the relationship with carbon cycle and also CO2 emission in such forests, mainly in Thailand. Without further much ado, I would like to invite Dr. Pongtep Hanpatanakit, to present, to deliver his talk this morning. Thank you.
Thank you, Dr. Ko, for introducing myself, and good morning, everyone. My name is Pongtep Hanpatanakit. I'm a lecturer at Srinakarin Wirot University in Faculty of Environmental Culture and Ecotourism. I will wait a minute. Okay. So I would like to present our research group in the forest carbon. We got the IFS International Foundation for Science to get scholarship. For today, I would like to present in the topic is soil exploration and net ecosystem production trend in Thailand and Malaysia. This is for the author for this project. The outline of my presentation, we would like to talk, followed by 5 topics, followed by this slide. For the first one, introduction. I think everyone know the effect of the global warming and climate change. For example, the average temperature increasing in the Earth's surface, so lead to the problem in many things. For example, human, plant, or the environment. Normally, the natural process to capture the CO2 from the atmosphere, we fix the carbon by tea and the alter vegetation through photosynthesis, and it stock carbon by leaf, stem, branch, and roots. After that, the plant it die, it decomposition and and throw the carbon to the atmosphere by the respiration and decomposition of the organic matter is the carbon cycle in the tropical in the forest ecosystem. The carbon stock, I talk about the carbon stock for the above ground as the leaf, stem, and branch, below ground as root, and the above ground plant biomass, and in the soil also. So not much year ago, I think around less than 50 years ago, we found that in Southeast Asia, the forest change to the agricultural and some country need to protect the forest because the forest area is rapid decreasing. So the structure and characteristic of the natural forest to the secondary forest is quite different. For example, the root part of the secondary forest is a higher ratio than the natural forest because when the tree is cutting to make a house or furniture or something like that, the root part is stand on the soil. After that, it leak again, lead to a carbon stock in the below ground part is much higher than in the secondary forest was higher than in the primary forest, for example. So the root part so important for study of the net carbon stock in the secondary forest. My group was study about the carbon balance in the forest as carbon sink and carbon salt. We call net ecosystem production or NEP. NEP on rate of the carbon accumulation in the forest ecosystem. We study by the equation 1. Equation 1 is NEP equal NPP minus RM. NPP is the net primary production and RM is the heterotrophic respiration. We call microbial respiration. NPP estimation followed by the equation 2. The equation 2 equal delta M is above ground living biomass increment plus delta CR is the causal root increment, LF is the above ground litterfall, and PR is the fire root production. Normally, before the study of the NEP in different sites in the world, we have not clarified for the PR is the fire root production. I think it's very important for the study of the carbon stock in NEP, especially in the secondary forest, as I show the effect of the root in the below ground is so high. This is a carbon plant in NEP. Normally the carbon sink by photosynthesis, and after that carbon salt by respiration. So respiration is equal by root respiration and microbial respiration for something in this graph. For the problem status of in this research, carbon sequestration in tropical forest research will not only provide the result on the carbon sequestration capacity of the primary and secondary forests in Thailand and Malaysia, but also consolidate the methodology on estimating NEP. The method should be as simple as possible with acceptable accuracy to apply in Thailand and Malaysia, where human resource and technology equipment are still limited. The objective of this study, we have 2 points. The first one is to study quantify CO2 emission from soil respiration in secondary diatropic forest at Ratchaburi province and both sites in Malaysia as partial forest reserve and secondary lowland forest in Jangga. Second one, to quantifying carbon stock flux in all the carbon pool lead to the estimating of NEP or net ecosystem production of some forests in Thailand and Malaysia. The conceptual of framework, we would like to know the NEP in Thailand and Malaysia. We have 2 parts to study. First one is carbon sink. We study at NEP and carbon salt. We study the microbial respiration. NEP equal above ground biomass or delta M, below ground biomass, and above ground little falls. Above ground biomass, we use the arithmetic equation. Below ground biomass, we have two parts. First one is the causal root. We use the arithmetic equation also, but the fine root production or PR, we use soil core method. I think our author presentation today, she is to talk the detail of the fine root production methodology and the result of the fine root production methodology. Above ground and little fall, above ground little fall, we use the little bucket. The size is 1 multiply 1 at 20 pot per each study. For the carbon salt, I use the cross automate chamber method and separate microbial and root respiration by using trenching method. All of the data we need to find NEP equal NPP minus microbial respiration. The material and method. The first one is the site study. In this research, we have RT site to show the result. First one is the secondary dipterocarp forest at Ratchaburi province, Ratchaburi, Western Thailand. Is the dipterocarp forest. The area cover 187 hectares. So the second one is PFR or Parcel Forest Reserve. Is the area of the forest was 1,840 hectares, and the last one is the SLF secondary lowland forest in Jangga in west in Malaysia. The area followed by the dipterocarp forest. For the soil respiration and climate factor measurement, I would like to show in Thailand first study. We use the trenching method for separate microbial and root respiration. It look like the soil and protect the root outside growing inside by using the CPAC and insert the soil, followed by this picture, and use the cross chamber method for analyze for the measurement the CO2 flux from soil. And this one is the climate factor for soil moisture and temperature. For the soil respiration in Malaysia, we use the trenching method also, same like this picture, and use the model automate soil CO2 system model LI 8100 model for measure the soil respiration, same like this. For the result and discussion, this table show the site description in different area, one site in Thailand and two sites in Malaysia. SDDF is secondary dipterocarp forest in Thailand. SLF is the secondary lowland forest in Jangga, and PFR is Parcel Forest Reserve. We found that in the Thailand, the stem density is too high, higher than in both sides of Malaysia, but the mean tree height is lower than in both sides of Malaysia. The DBS is very small, around 6.55 centimeter, but SLF and PFR is higher than in Thailand. The basal area, the T in Thailand, so very small because it's the secondary dipterocarp forest and it regrowing maybe 10 years ago, but lead to the pan in above ground is very small, but the density is too high. The air temperature between Thailand is very hotter than in two sides in Malaysia. The range of air temperature as 24 to 42 degrees Celsius, but SLF and PFR is lower than around 20 to 29 degrees Celsius in air temperature. The range of soil temperature around in Thailand around 21 to 31, and in Malaysia around 24 to 25 degrees Celsius. The range of soil moisture in Thailand is quite dry and douse area. The soil moisture around 24 to 31% water fill prospect, but in two sides of Malaysia is very high, around 41 to the 60% water fill prospect. The rainfall in Thailand around 1,000 millimeter per year, but in two sides of Malaysia is 1,800, something like that. The forest size is of the tropical forest. These figures show some results of the diurnal variation of the soil respiration, microbial respiration, and root respiration in Thailand. We would like to compare between the dry season and wet season. We found that the soil respiration, root respiration, and microbial respiration was increased followed by the soil temperature uh, as both of the season in dry and wet season. But during dry season, the CO2 flux from soil is lower than wet season. The monthly variation of soil respiration in Thailand, we found that the monthly from Jan to December in 2019, and y-axis is the soil CO2 flux. We found that during dry season, the CO2 emission, on November to April is quite low compared with the wet season. And we found that the microbial respiration was higher than and controlled the CO2 emission from the tropical forest in Thailand. But you can see the root respiration between wet and dry season is not quite different. The ratio of the RS and RM and RM and RS and RR and RS, the ratio of RM and RS equal around 80%, and RR and RR per RS is 20%. The relationship between soil respiration, root respiration, and microbial respiration with the climate factor, we found that the soil respiration was positive correlation with soil temperature. Microbial respiration, soil respiration, microbial respiration, and root respiration was positive correlation with air temperature, soil temperature, and soil moisture. Followed by this, the result of comparison of the soil respiration in 3 sites, we found that the results show that the February to October during 2018-2019, we found that SLF and PFR, the soil respiration was higher than SDDF in Thailand. The air temperature and soil temperature of T size between T size is not quite different, around 20 something. But the soil moisture in Malaysia, or both sides of Malaysia, is what higher than in Thailand. Thailand is quite very drought area. You can see the pink, the orange line as shown in this figure. The ratio of the RS per RM per RS and RR per RS, we found that the y-axis is soil CO2 flux and x-axis is the different side of study. SRF in Malaysia, the average soil respiration equal 494 milligram carbon dioxide per square meter per hour. The PFR in Malaysia also, the soil respiration equal 482. And last site study in Thailand, the average of CO2 emission from soil equal 386 milligram carbon dioxide per square meter per hour. The ratio of emission from the microbial respiration in Malaysia around 81 to 86%. In Thailand, the microbial respiration ratio around 77%. And the soil temperature and temperature between T side is not quite different, but soil moisture in Malaysia were higher than in Thailand. The relationship of the soil respiration and climate at T site study, we found that the soil respiration and microbial respiration was positive correlation with the soil moisture, something like this. And soil respiration and microbial respiration was negative correlation with soil temperature, except the root respiration. The results show that didn't to significant of the soil moisture and soil temperature. It's possible to read the some research said that the root respiration may be correlate with the net solar radiation, because net solar radiation is effect to the root respiration as a maybe mechanism in the photosynthesis, for example. But in our research didn't to show that the correlation of the root respiration to the soil moisture and soil temperature. So I would like to conclude the net ecosystem production, or NEP, in different sites, at 2 sites in Malaysia and 1 site in Thailand. The above biomass, coastal root, little fall, fire root production as a total NPP compared between SLF, PRF, and SDDF. We found that NPP equal 6.19, 7.3, and 15.5 ton carbon per hectare per year. So the microbial respiration of SLF, PFR, and SDDF were 8.9, 7.52, and 1.1, 7.1. The finding of the NEP for 3 different sites in Thailand and Malaysia, we found that SLF was minus 2.71, PFR was minus 0.22, and SDDF was 8.43. For the conclusion of the topic, I would like to finding the NEP and the relationship of the environment, such as the air temperature, soil temperature, and soil moisture for control the CO2 emission from soil. And NEP in Thailand, in my site, was the can capture carbon in the atmosphere is if I think in our side in the secondary dipterocarp forest, the plant is higher growth and can capture the CO2 from atmosphere to plant growing. But inside of Malaysia is the carbon loss from the NEP, maybe some, for example, Paso area is the natural forest, and secondary lowland forest in Jangka. The research said that the around in this forest have land use, for example, a grow pen or the rubber tea plantation for something like that. It's some effect to the soil exploration. Yeah, that's all of my presentation. If you have some question or suggestion, you can ask to me after that. Thank you very much.
Thank you, Dr. Pongtep. Thank you very much for the exciting and wonderful presentation and talk regarding your work. We are basically on time. I would suggest one or two important critical questions that you would like to ask Dr. Pongtep with regards to his talk today. Any questions? We will pick it up from, I will pick it up from the chat room. If you have any questions, please put it up onto the chat room. We will pick it up right now. At this moment, I don't see any burning question. I would like to slightly bring the topic towards Dr. Pongtep's slides where you showed the formula on NEP, the theory of calculating NEP and MPP and all that. I think it's really useful. We would like, I would like to also to take note that this equations basically, it really depends on those who does all these work on NPP and NEP. It's quite it varies quite a bit, but the principle and the concept is similar. So
Yeah.
it will be interesting to see that if we have, if you will have a similar or comparison of a formula that you would like to put it into the equation. For example, Paso forest and your dry dipterocarp forest in Thailand, we may use different sort of formula to calculate. For example, we may put in litter falls, or we may put in coarse woody debris. We may put in a little bit more on herbivory, for example. All these things can slightly change the sort of your values and your average when we calculate it. So it'll be really interesting. There are quite a number of literature reviews. There are quite a number of review papers that sort of compare different equations to fit in different inputs, different outputs. And this will be really interesting to gather all these information together and see where we want to limit our equation. We can put in above ground biomass, all sorts of inputs, and then below ground, very, very detailed inputs, depending on how much we measure. I think this will be quite interesting to look at in the future, for example, if possible. I still don't see. I still don't see any questions. Perhaps you want to comment on that, or we can go on with the next one.
Okay, I will stop share right now. Thank you so much.
Yeah, I don't see any questions. I hope this will be a lively discussion this morning. Maybe we're just starting. Everyone is just warming up in different parts of the world. So we will continue with the second. If there isn't any other questions, no one wants to raise anything. Perhaps I see one. Can I just quickly pick this one up before we move on? Okay, there is one question if you want to respond to this. Based on NEP, net ecosystem production comparison on slide 24, what is the possible factor that caused the value to be different, although they are forest?
This slide show that in my opinion, we found that the factor for the control NEP in different sites, the one part is the carbon stock in the NPP. In the two sites at Malaysia is the natural forest, something like that. The above ground increment in biomass is quite low. And the soil respiration in microbial respiration in T site is not quite different. You can see that, but this part of the above ground biomass in Thailand is so high, and the little fall, you can see that in Thailand is 6.22 ton carbon per hectare per year. I think in our side is the decidual forest, the leaf it fall during the dry season, and the production of the little fall in our side in Thailand is too high. I think it's two parts for difference between Thailand and Malaysia, and lead to the NEP is quite different also.
Thank you, Dr. Pongtep. I hope it answers the question, but we will bring this on. If it doesn't answer the question, we will bring this on towards the end of this webinar, where we will have a discussion, panel discussion, and also question and answer. Thank you very much for the question. I think everyone is warmed up now. Let's move on to the second speaker. The second speaker will be Mr. Afzanizam Muda. He is a research officer in the Forest Research Institute of Malaysia, also known as FRIM. He has been working there since the next speaker, as I explained earlier, is Mr. Afzanizam Muda. He is from Forest Research Institute of Malaysia, also known as FRIM. Now, he has his experience in FRIM since 2014 until now, and he used to work in Research Consultancy Unit, University of Malaya. As a research assistant, he has affiliation in various organizations, various society, for example, Malaysian Society of Waste Management, Malaysian Society of Plant Physiology, Malaysian Nature Society, and all sorts. He has all these affiliation with all these important organization and society. He has some publication on basically on carbon stocks and also in biomass, working in tropical forests, mainly in pasture forests and also different parts of Malaysian forests in Malaysia. Today, he will be talking to you for 25 minutes he'll be sharing about his experience and also his work, mainly in Malaysian tropical forests. I will leave it to Mr. Afzal Nizam for the next 25 minutes. Thank you very much.
All right. Let me share my screen. Thank you, Dr. Ko Lit Kun, our moderator for today, for the kind introduction. Good morning, good afternoon, or good evening to everyone, wherever you are. So we are glad for all of you to join us to listen to our research findings and knowledge sharing on our collaborative research grant output on estimating of net ecosystem production in tropical forests of Malaysia and Thailand. So I'm not talking a big or broad subject here, so I'll be picking up a little bit on the below ground aspect of the forest, which is on the root decomposition, specifically on fine roots. So the topic is the trends in annual root decomposition in selected forest soil. So the objective is basically to detect root decay rates at a predetermined sampling time in lowland forests of Jengke Forest Reserve in both our plot in Malaysia, which is in Jengke Forest Reserve, and also Paso Forest Reserve. So a little bit on the site description, I think this has been mentioned a lot. Just a quick snapshot on our two sites in Malaysia. In Jengke is a secondary lowland forest in Pahang, whereas Malaysia, this site was chosen as secondary data were available from the previous study. Also known as Jengke Virgin Jungle Reserve, VJR, located at 50 to 90 meters above sea level with slope ranging from 2 to 8 degrees. It's a rather lowland, flatland, sorry. And the soil type recorded here is silty clay loam from the Durian series. So the plots there are 6 plots altogether, measuring 10 meters in Jengke Forest Reserve. As for Paso, the fine root decomposition study were conducted at a 1 hectare tropical ecology and assessment and monitoring, or shortly known as TEAM plot in Paso Forest Reserve. And just a little bit on the climate variables, the mean monthly relative humidity, or RHH, range from 70 to sometimes 100% during wet months, and between 80 to 93% during the dry months. Mean annual temperature between 20 and 29.3. Maximum temperature and mean annual precipitation or rainfall will be between 51 millimeter and 4 to 9 millimeter during the study period, which is 2017 to 2019. And the soil type recorded, particularly at our site, is coarse sandy, around 49 to 59%. So this map shows both our plot in Malaysia, was in Paso Forest Reserve in central region, and we have Jengke Forest Reserve in Jengke Virgin Jungle Reserve in the western part of Malaysia. So why fine root, and what is it actually? Why is it important to trees, and especially on the below ground studies? So first of all, we need to define what is fine roots. So fine roots are roots with diameter of at least 2 millimeter and below in diameter. They are small but functionally important component of a plant biomass, which controls the uptake of water and nutrients and influences the biogeochemical cycles through rapid biomass turnover in the below ground. And the lifespan of fine roots in particular are very short. From the smallest first and second order rootlet is short, in woody plants, typically not more than a few months. So this is the first rootlets, if you can see. And then the second rootlets branching out from the first order rootlets. And the picture we show here is a digital image of fine roots stained with methylene blue observed under electron microscope. And despite the short lifespan of fine roots, and they represent a few percent of plant biomass. Yes, they are very small. However, fine roots have been estimated to consume about a third of annual global net primary production, or NPP, which is the component of the NEP formula. And they represent a major source of soil carbon through root depth and rhizole deposition. Okay, we go straight on to the field experiments. So this diagram you see here is the snapshot of what that summarizes what the fine root decomposition study in situ measurements looks like. So from step 1 to step 5, we start with the soil coring placement and mesh bag installation, and the mesh bag retrieval, and also the debris sieve before we bring into the lab, and then for lab analysis for wet weight and dry weight. So specifically, this is how the step-by-step of fine root decomposition stage. First, we take the fine root between 0 to 5 centimeter, and we wash the roots from soil. And then from there, we bring to the lab for oven drying, and then we weigh the remaining of fine root biomass. This is the fine root decomposition. And as for the root biomass, in order to do the decomposition, we need to determine what is the biomass first. So we take the fine root sampling for 20 centimeter at 20 centimeter depth. So between 0 to 5 centimeter, 5 to 10, to 15 and 20 centimeter. And from extract roots from the soil, like for oven drying, and we weigh the fine root biomass. That's how the fine root biomass and decomposition measurements happen on the ground. So we go straight to the main output. So what you saw here is a trend of root mass loss in Jungle Forest Reserve and Paso for 360 days. So there are 4 intervals, 120 days, we retrieve, and then we have another 240 days, and then also we have for 360 days. And you can see they are very much the goodness of fit shown in the R2 spec, 0.93 for Jungle, and also for Paso, which is 0.93 as well, shows the goodness of fit of the exponential model. So this is the typical trend of root mass loss. They follow the negative exponential model. So a little bit discussion on the trend of root mass loss. The single exponential model decay, according to Olsen, was adapted due to its simplicity and better goodness of fit, shown by the R square value for the initial decomposition stage during the early stage of the decomposition process. And they are typical inverted J curve. This is what I call typical J curve. The root remaining loss against time. This inverted J curve or negatively correlated model are used to explain the relationship between remaining root biomass against time for 3 intervals, which is 4 months, which is 120 days, 8 months, and 12 months intervals. And we see that the rapid decomposition in the early stage, it's very common, and gradually decreasing over time. So how do we determine this? Using the K value, which is the decay constant, which I'll be showing later on. And weight loss for Jungle Forest Reserve was slightly faster compared to Pasu, as rapid decomposition took place at 120 and 360 days. And however, a more rapid trend was found for Pasu at 240 days, which is the optimum. After 360 days, which is after 1 year, the remaining routes were close to 50% and 55% for both the Jungle and Pasu respectively. And to our knowledge, this is the first study on root decomposition done in tropical forests of Peninsular Malaysia. So this is the analysis formula in order to calculate root mass loss and also the decay rate, the K value that I mentioned earlier. First, in order to do the percentage of mass loss, we calculate by using the initial mass minus the final mass divided by initial mass times by 100. So the mass loss was conventionally expressed in percentage. And the dry root mass percentage remaining at time t was calculated according to the formula below. So whatever loss, the remaining mass is the mass loss in percentage subtracted by 100, then we get what is remaining from the root mass. And as for the decay rate constant or K value for the root mass were calculated using a negative exponential model. So K value here is the natural log of final mass, which is the dry weight over initial mass, which is the wet weight, divided by the time t. So x0 is the initial dry weight of the root, and xt is the weight of the residual root of the time t. So this is very much conventional way to determine using the wet weight and also dry weight for both liter and also fine root. And t is the sampling duration in months. So this is a graph show the decay rate constant for 3 intervals for Pasu and Jungle. Pasu is coded in gray and Jungle is in orange. So for 120 days, you see from 0.06 to become 0.13 for 240 days, and slightly slower after 240 days to become 0.14. And as for Jungle, you can see they picked up quite fast. I mean, the decomposition or the decay rate quite fast from 120 days, which is 0.07, and for 240 days, 0.08, and it shoot to 0.2 after 240 days. So the decay rate constant or K value basically show how fast the fine root decompose or decay in our site. And since generally decay rate constant or K value are expressed in per day or per year basis. As I mentioned, a rapid loss of mass initially followed by a period of slower loss. Rapid decomposition took place in Jungle Forest Reserve as compared to Pasu Forest Reserve due to the enhanced mean annual precipitation, which may have facilitated the decomposition process with decreased soil moisture availability. So we suspect that precipitation and rainfall facilitate the decomposition process faster in Jungle, and therefore increase the soil moisture availability for soil microbial activity. I picked up some of the K value, what it looks like around the world. So the K value here is non-exhaustive. So I just picked up from the literature based on sites. So I managed to do for Peninsular Malaysia for this study. The K value is 0.8 to 0.9. And we take, for example, in the US, for conifer trees between 0.17 to 0.13. And also for China, we have mixed forest fell between 0.7 to 1.44, which is very, very high. And also for China, we have a bamboo forest plantation, another type of forest plantation between 0.49 to 0.53, slightly lower slightly lower than natural forest. So basically, the key value, the higher the key value is, shows the faster decomposition takes place in the ground. And based on our calculation, the annual key values and the exponential model for jungle forest and pasto for our findings concurred with previous study for tropical region. And how about the climate factor or variable? So we take consideration for air temperature, mean air slightly lower than jungle, and the minimum rainfall is at 31 millimeter. This is during dry season. And the average rainfall for pasto is around 1,800, as I mentioned earlier. And for jungle, it's quite almost the same, which is 1,800 millimeter. And the temperature for pasto range between 20.1 to 29.3. And as for jungle, the temperature between 26.1 to 27.5. So here you can see the trend in between January. We take one variables on rainfall, for instance. From January, it started to decline as it probably due to weather transition, and the amount of rainfall decreased drastically. And then towards the end, it picks up between August to November 2018 for pasto. It picks up in terms of rainfall volume. And we can see also for jungle between September and December, not so much differentiation in terms of volume of rainfall. So for final decomposition in both sides differed in their responses to climate, in this case, mean annual precipitation and mean annual temperature. For instance, during the 2-year study in pasto, it is observed that although minimum and maximum air temperature fluctuation are high, temperature exerted somehow slow effect on final decomposition process, explaining remaining roots was still half, close to 50% and 55% for jungle and pasto, even after 1 year of retrieval. In temperate region, it takes even longer. Even after 2 years, just still 50% of the fine roots still remain intact. And the literature also mentioned that the mean annual temperature exerted a stronger effect on coarse root than fine roots indicate constant K values, which in this case are yet to be proven, since coarse root data is not yet processed for now. And mean annual precipitation or rainfall was positively correlated with the decay constant of fine roots, as reported from previous study, around 0.75 per year. So as a conclusion, the relationship between decomposition constants, how fast the fine root decomposed on the ground, and the controlling factors, in this case, two climatic factors, temperature and rainfall, were statistically significant. Our results provide new insight into root decay constants related to climate in contrasting sites in tropical lowland forest, and subsequently may assist to predict the response of below ground carbon. This includes soil and nutrient cycling that release back to the above ground and contribute to the climate change on site-specific variability. I think that's all. Thank you.
Thank you, Mr. Afzanizam, for the interesting talk on decomposition from Paso Forest mainly. This gives plenty of insights into what has been done in Paso Forest with regards mainly to decomposition of fine roots decomposition as well. I see several questions. It's quite interesting. I think it's directed to your talk.
Okay.
Or perhaps I think this is a little bit more we could discuss in the panel discussion later, or I mean in the discussion later towards the end of our webinar, where we have a discussion among all the panelists. I think I will pick these questions later. If there is any question to Mr. Afzanizam pertaining or related to his talk this morning, directly on his paper or on his talk, could you please send it over to the chat room so I can pick it up at this moment? One or two questions, one or two important questions will be interesting to get him to answer. I'm particularly interested in fine root study because it is very challenging. It is a very challenging task. It is a very challenging experiment to do, especially when we have to deal with undisturbed situation in below ground sort of condition. And if we conduct experiment below ground with sort of any of our methodology and techniques that we do, we will need to employ various corrections, various caveats to the results that we get, I think. I think I have one question here from Dr. Jayani. How do you think the decomposition differ between litters and roots? Do you have?
Yeah, thank you, Dr. Jamie, for the questions. This is based on my understanding. I think what may differ between litter and root decomposition is the external factor or environmental factor like temperature and rainfall, which is, I think, very general. But I think soil quality or soil nutrient maybe have something to do with the decomposition process between litter and roots. Yeah.
Thank you. We can bring this up into the discussion again. I think I would like to point out, based on my experience, litter decomposition varies in between different soil types. Different soil types has different nutrient content. For example, my experience in Lumber forest, Lumber dipterocarp forest, you have the sites where it is very fertile and the sites where it's infertile. And the infertile are pretty much at the higher elevated sort of hilly sort of terrain. And these hilly terrains, when they are infertile, when they are low in nutrient contents, they tend to have leaves that are what do you call it, thicker leaves with lignin contents and all that. So when they try not to lose their leaves as much as possible during droughts or different environmental situation. And if they keep the leaves and if they drop the leaves, the thicker leaves would take a longer time to decompose. I think these are the experiences that we found out, that we discovered in Lambir forest. I think it could be quite an interesting sort of factor to consider in Paso as well, where they have different nutrient contents, and of course precipitation plays a role as well. Thank you very much. I think that's it for now. I want to move on. Our time is doing well. I want to move on to the last speaker. Thank you very much, Mr. Abza Nizam, for the interesting talk and for clarifying one of the questions that we have. I want to move on with our last speaker. That's Dr. Jayani. Dr. Jayani Vijayananthan. He is a senior research officer. His position in FRIM, or Forest Research Institute of Malaysia, is in soil science. She is a soil scientist. She graduated with her PhD in soil science in 2015. She has a master's in soil fertility and management. She also holds a Bachelor of Science in Agriculture. Now, her specialization includes soil chemistry, fertility, precision agriculture survey, and plant nutrition management. Her current research interest spans on environmental soil science, regenerative agriculture, carbon stocks and fluxes, and natural plantation ecosystems. At the same time, she is also a certified chemist in the Institute of Chemistry. She is currently the Vice President of Malaysian Society of Soil Science and a member of the FAO Soil Pollution Working Group. She has 16 years of working experience with all these specialization and research interests that she has. Thus far, she has published 5 books, chapters in books, about 4 journals, about more than 25 different Q1, Q2, Q3, Q4, and also a proceeding editor, and 12 of the proceedings and papers in proceedings, more than 50, I suppose. This is a wide range of papers and publication that she has published. She also won several awards, Best Research Awards on Rehabilitation Management, peat on forest. She's involved with peat forests, and also Publication Award in Bacterial Communities. Today, she will be talking about fine root dynamics, mortality, decomposition, and slightly similar, which is interlinked to the 2 presenters earlier. And without further much ado, I would like to invite Dr. Jayani to present her talk this morning for the next 25 minutes. I hope you keep your time. Thank you very much. Over to you.
Thank you very much, Dr. Ko, for such a generous introduction. And also thank you to all my colleagues. I'm not sure whether you are able to hear, but it's raining very heavily here from where I'm going to present today. So forgive me if my internet connection falls and comes up later. All right, I hope that all of you are able to look at the slide that I'm sharing. So a good morning to all the participants who are here today. So thank you, Dr. Tab, as well as Mr. Nizam. You have done a very good introduction of actually explaining what is NEP all about, and have made my work much more easier. Just to recap, I'll be presenting on the fine roots dynamics and the overview of collaborative research in Malaysia, Vietnam, and Thailand. Of course, our project leader is unable to join us today, Dr. Tran Wando. But however, we'll be doing whatever that we need to present and share with you the data that we have collected. So this is the outline of my presentation. I'll be briefly talking about fine root dynamics in my presentation. Then I'll move on the experimentation part. What did we do in 3 different areas? Then I will guide you into the results that we got between 3 sites. That would be the Jangka, Paso, and the Ratchaburi site. Finally, I'll be concluding concluding the research that we have done and also discuss on the results that we got in concluding remarks. The last part of my presentation would be actually, I'll be sharing some of the pictures as well as the workshops that we have attended during our tenure as the IFS grantees throughout this funding. So, ladies and gentlemen, as you know, Malaysia is one of the country which is quite rich in, forest resources, mainly tropical forests. Almost 61% of our land is permanent forest reserve, and the biggest chunk of the forest in the Sarawak area, where Dr. Koh hails from, followed by Peninsular Malaysia, 31.5%, and finally Sabah. Of course, our forests are heterogeneous. I have to thank Dr. Hamdan Omar, our colleague who shared this slide with me. We have forests from the highest elevation, about more than 1,200 meters above sea level, up to the coastal mangroves, less than 100. And these differing forests at different elevations as well as area actually gives you different types of microclimate as well as microhabitat for the tree species as well as the faunal species. These are some of the variations that we had to take in when we are even doing the net ecosystem production work in our research. So, ladies and gentlemen, NPP is the amount of photosynthase that is not used for respiration and is available for other processes. Of course, most of us are quite familiar that fine roots play an important role in plant nutrient dynamics, where these are the roots that actually absorb nutrients from soil. However, due to the current scenario on climate change, there is also a need for us to determine the fine roots ability in the global carbon cycle. Studies by Mali et al. As well as Jill and Jackson have actually mentioned that fine roots actually constitute 10 to 60% of the total net primary production in tropical forests. So in these slides that I'm going to share with you, it will be basically to ask how do actually fine root dynamics, mainly the fine root necromass, the decomposition as well as the production, differ with temporal variations in the areas that we are looking at, and how about the contributions of litter fall to the fine root dynamics as well. So just an image that I've captured from Meng et al. 2018. The fine roots that we are talking about is here. You can also see the necromass that we have collected firsthand at the soil, at the tropical forest that we have worked on. So we have 3 study sites. I may not want to dwell too much on this because it has been explained very well by Dr. Pongtep as well as Mr. Nizam. So these were the methods that we did in order to collect the fine root decomposition. Firstly, even before we started the experiment, we went into the forest. We collected a big bulk of roots, about 5 kilos. Then we segregated it. We brought it back to our lab, and then we prepared these very nice looking mesh bags, with very minimal pore sizes, which only allows microfauna to get in to do the decomposition processes. Of course, these mesh bags were nicely buried under the soil in each of our sites, and we collected the mesh bags almost every 4 months. Once we collected it, what we did was that we washed it off from soil and debris, and then we weighed it, we oven dried it to make sure that we got the amount of fine roots which has been decomposed. Secondly, to estimate the fine root biomass, we use iron cores. We bored it through the soil. You can see it here, and then when we brought it back, this involved a lot of work. I'm sure Mr. Nizam and Dr. Tab would agree with me. We had to wash it off using sieve in order to remove the soil, the debris, and then we had to hand pick all the roots. It was not easy work. I think Dr. Kaur would agree with me as well. Then finally, that would be the litter collection. What we did was that we fixed 1 meter by 1 meter netting in the forest area. Then we collected the litter fall from the from the trees. This was also done every 4 months. When we brought back, we cleaned it, we oven dried it, and we got the amount of oven dried litter fall, which I'll be showing you the various weights that we got later. So ladies and gentlemen, Dr. Pongtep has already introduced to you these two equations on how to estimate the net ecosystem production. So part of the net primary production would be the fine roots and the litter fall fragments. So for fine root production, this was the equation that we use. This was after Osawa and Aizawa, a paper published in 2012. FRP stands for fine root production. Your FRN is fine root necromass. Fine root decomposition constitute FRD, and D is the decomposition. The value that you see here is the decomposition ratio. So I will move quickly into results and discussion to share with you the values that we got between these three sites. So the climate that you see in Jengke and Paso within the Peninsular Malaysia, it's quite similar. We get a dry distinctive period between the months of February to April. You can see that the excuse me, the temperatures are elevated here. And then you have the wet season, which starts from October up to January. Similar patterns are also captured between October 2017 and October 2018. However, in Ratchaburi, the dry distinctive period is between the months of January to April. You have elevated values of temperature, but very poor rainfall. But they have seem to have more months of rainy days. As you can see, start off from May up to October. And then the pattern goes down again, where you have another similar dry period. So these are the values that we got after we did the processing of the samples. As I told you, we collected the samples every 4 months. So we are showing you the values for a year, which is for the February, June, as well as October 2018. Of course, our experiment went on much more longer than that, but just for this presentation, I was able to capture this data to share with you. So note that the fine root biomass in Ratchaburi is much more reduced compared to Jengke and Paso. So we had this discussion among our colleagues, and we came to a tentative conclusion is that this is due to the dry dipterocarp forest, which has a prolonged time in the dry season, which actually which actually reduces the soil moisture values in the soil, thus not allowing the amount of fine root biomass to accumulate much more faster as compared to Jengke and Paso. Also bear in mind that the root decomposition ratio in Ratchaburi was much more smaller, much more reduced to the Malaysian side. Jengke had about moving from 0.2 to 0.5. Similar was for the site in Paso. So when the root decomposition is also reduced, more or less the amount of fine root biomass that we get in the soil is also reduced in the area. And for the area in litter fall, we saw that Ratchaburi had the most amount of litter fall, which happened in the month of February. That was during the dry season, I believe, compared to Jengke and Paso. But the amount of litter fall which was in Paso was generally much more lesser compared to all three sites. all the data that we collected for February, June, and 2018 were further processed to show the annual production of fine roots in the line of fine root decomposition, necromass. What we got was that among all three sites, more or less, the values that we got for Jengke and Ratchaburi are more or less similar. But for Paso, we got high increments of fine root necromass. That means the amount of root death which is happening in Paso is much more accelerated compared to two other sites in Ratchaburi and Jengke. So we have many factors that we may want to relate with this phenomena, because you see both all three sites, Ratchaburi, Paso, and Jengke, host different types of tree species, different types of soil quality, as well as soil types. For example, just to compare between sites, in Paso, the soils are much more coarse grained, more sandy compared to Jengke. So the processes which is being done by the microbial activities, the nutrient holding capacity of the soils may differ very greatly, and this may have somehow excuse me, affected the different values that we get in the fine root decomposition, necromass, as well as fine root production. However, when we look at the litter fall, bear in mind that the slide that I showed you before showed that there was an increment of litter fall in the month of February in Ratchaburi. But when we collected these values for the annual litter fall data, what we saw was that the highest was in Jengke, followed by Paso, and lastly Ratchaburi. Like in Jengke, based on my experience, what we saw was that whenever there's a wet season, when we go in during the wet season, the amount of litter fall that we collect is pretty abundant. This is mainly due to the growing season of the site, as well as the processes related to leaf abscission when wet season occurs. Of course, there are many other factors, probably plant trade analysis that we may have to do, as well as the values for the lignin content in the litter fall, as well as the roots, in order to explore further why these variations occur between these three sites. So, ladies and gentlemen, I would just like to share with you some data on the fine root production in different countries. So, for this study, what we found was that the amount of fine root production was in the range of 0.75 to 1.68. They were not too far from results which have been published in Lambe, Malaysia. I think this paper relates to Dr. Koh's work, as well as Paso, which was one of the earlier work done by some of the Japanese scientists there in 1998, and also to other countries such as Peru, Sulawesi, Indonesia. Of course, different areas, different site specifics gives you different fine root production, and it's always important to capture these intra variations in our study in order to get this information to be fitted into much more bigger regional or global carbon cycle modeling works, which will be carried out and which is also going on right now. So just to recap, from the site which I worked on, I think this has been produced by Dr. Tab just now. So fitting in the litter fall as well as the fine roots, which carried the biggest ratio in the accumulation for the net primary production, which is close to 60% for litter fall and 24% for fine roots. We found that the site that I was working at was actually not a sink, more of a source, which was 2.1 megagram carbon per hectare. We are still working on the data for 2019 as well as 2020. So once we have those, probably we may want to share with you in a published paper. So the concluding remarks for the study that I did was that, of course, the comparative studies that we did between the evergreen tropical forest and dry dipterocarp forest revealed that the general concept of seasonal variations was there, for the fine root dynamics as well as litter fall. There were other factors which were not factored in, but should have been included, such as the microfaunal species, the soil type, the root resilience, meaning that the lignin content in the root, how fast does it decompose, as well as the microclimatic factors. Of course, the values for the fine root production that we saw just now in the previous slide was more or less in the range with other tropical sites that, such as in Brazil, Peru, and Indonesia. The leaf litter fall was the highest due to the wet season, which actually allows higher leaf abscission. So, ladies and gentlemen, we actually found that these two components play crucial roles in carbon turnover rates. And in future or the way forward, we suggest that more sites should be experimented with long-term monitoring. Bear in mind that 1 year data may not fit into the work that we are doing. This has to go through probably more than 1 year in order for us to capture the differences in the intra as well as the intervariations. Of course, values derived from the studies can be fitted later on for global carbon modeling. With the current race to net zero, I'm sure all of us here are quite familiar with that. How do actually tropical forests play an important role? So this question can be taken up in the Q&A session later, but I came across this article which mentioned that tropical forests are actually reducing its capacity in behaving like a carbon sink. Why? There are many factors related to that. So it is time that we look at how we actually manage our forests in present as well as in future in order to reach the target set for the net zero emission. So I have actually concluded for the experimental part that I have prepared for today. So let me just share with you our journey, all four of us. How did we came about from different countries to be able to do this collaborative research? Of course, the Forest Carbon team was initiated in the mid-2016. Our project leader was Dr. Tran Van Do from Vietnam. We actually started off chatting in a group, like a Zoom chat like this, which was done by the IFS. Then we decided to link our expertise with each other who was in the same field. Then we applied for the project. The first workshop that IFS-SEARCA conducted was in Los Baños, Philippines, in the month of August in 2016. This first workshop was very important for all of our collaborators to sit in, work on the proposals. There were mentors there, teaching us on how to make our proposals much more stronger in order to get the funding. And then the second workshop, unfortunately, I think all of us were unable to go except for Mr. Nizam, who took time to go. He's sitting here with the director of IFS, Prof. Nigisti Gize, on talking on the monitoring work and the work that we have been doing so far in our research in all our respective sites. This workshop was conducted by our project leader. I have to thank Dr. Do, because all of us were quite unfamiliar with the work related to net primary production in NEP until he gave us some introduction on that. There was a course that we did. We also had hands-on experience in Vietnam, how to determine the fine roots calculation and dynamics. And this workshop was very important for us to come back to our own sites to do the experiment. So besides IFS and SEARCA, I also would like to thank a lot of other scientists as well as, informal collaborators whom I had discussions, such as Dr. Muhammad Firdaus, who actually borrowed the LICO equipment when I didn't have one, in order for us to measure the soil respiration. Dr. Liang Naishen from NIES, who showed some of his work from the area that he's working on in Paso. Prof. Benjamin Bon Lamberty, that we were able to discuss during the Asia Flux 2019 International Conference on Respiration, as well as the support team from LICO USA, who was able to give us advice as well as, do some troubleshooting, remotely when they were not available on site. So these are some of the publications which were generated from the work that we did. We are still planning to co-write manuscripts on 3 different sites. Once it's ready, we will share it with you. And at the moment, I'm preparing a manuscript on the fine roots, and it will be published soon. And once we have it, we will put it up in the net. So, ladies and gentlemen, I would like to end my presentation today. Of course, I would like to acknowledge all these parties who have played vital role in our projects, the IFS-SEARCA, the local co-researchers, my very, very dedicated support staff from our soil team, as also the 11 Malaysian plan funding, which actually provided for the funding to buy the equipment. We also like to thank the FRIM ICT and Corporate Communication Department for helping us with setting up this webinar as well as troubleshooting. So that is the end of my presentation. I would like to thank everyone as well as MSSS which supported this webinar by promotion. Happy Earth Day, everyone.
Thank you, Dr. Jayani. It was a very informative and very interesting presentation. Right on the dot. You are basically very much on time. Thank you very much for keeping with your time. We have another about 15 minutes more to go for this webinar. I would like to invite, before we go into questions, and then later on into our discussion, I would like to get everyone to turn on their camera, video camera. We would like to take online photography, if that's possible, for everyone who is online this morning and who has been following us until this point. And I hope you don't leave, because we will have a burning discussion later after this. I see some questions already up. Thank you so much for turning on your video camera. So our Miss Atira should be able to take a photo for our session. Do we get everyone on? Can we get more of everyone? I think you ran out of time to buy a video camera right now, so you just have to make do with whatever you have. Okay, should I say 1, 2, 3, and then we say cheers?
Okay, sorry, I'm ready
or
to
cheese,
join.
or cheers.
Please, Simania. Okay.
Thank you very much.
Yeah.
Okay.
There are seven parts of it, Miss Atira. Hopefully you can capture all of them. Yeah. Thank
Yeah,
you.
Yeah,
I'm trying.
thank you.
Okay, so just keep your cameras on until she says you can off your camera.
Yep.
Yeah,
Oh.
so just keep smiling.
Yeah. Thank you.
Okay, that's
How are you,
one.
everybody? Yeah. Actually, I mistake. I read from email.
Okay, I think I get every one of you that open the camera, so you can off now.
All right. Thank you. Thank you.
Thank you. Thank you so much for your participation. We are not done yet. I would like to pick up one question first for Dr. Jayani. Just one quick question for Dr. Jayani it was provided by Mr. Posun, if I'm not mistaken.
Okay.
He was asking on fine root decomposition and fine root turnover. The differences of these two, how do you differentiate between root decomposition and root turnover? Are they similar, or do they have a different definition? Thank you.
Okay, thank you, Mr. Chiu Posun. We are so happy that you are part of our seminar today. He's actually one of our MSSS fellow. Yes, Mr. Posun. What the fine root decomposition study was done simultaneously in all 3 different sites, and we followed the same protocol for all sites. So that is to answer your question. On the second part, on the part on fine root turnover, there is a certain calculation that you have to do. I have the equation for that. So once we get the amount of fine root decomposition, you need to minus it off with the fine root biomass and also times it with the fraction, carbon fraction. Only then you will get the fine root turnover. So that is the answer to your question. But if you are interested to know more, I'm willing to share with you the methods later on. I think there's also, he asked, what is the destructive, also as destructive sampling involved? How do you account for the variations involved when sampling over time? So what we did was that when we determine the fine root decomposition, we put in a certain amount of weight of samples, probably 10 grams of root, or more than that, or 5 grams of roots in the mesh bag. So when we collect the mesh bags, there would be a certain decrease in the fine root with related to time. So we will calculate the decomposition at that time, and also find out the amount of fine root decomposition which happened during that period, as well as the annual root decomposition. I hope that I have answered your question on that explanation, Mr. Chiu.
Yes, thanks for being proactive to go into the next question, because I was supposed to pick it up. But I just want to add as well, with regards to question number 2, that accounts for the variation or the sampling over time. We know that this is below ground sort of experiment, below ground work. It's very tedious and it's challenging. So some of the ways that we try to do is to have different methodology working on the same time. For example, you have in-growth cores, and then you have mini rhizotron or scanning of roots at the same time together running, so you can actually check the differences between them, and you can actually check your variation. Another sort of way is to, I think this has been conducted as well. Another technique or another method is do it staggeredly, or perhaps do it in a different timing. You have all your samples, or you have all your methods or your techniques placed into the soil. For example, let's say you're doing coring or in-growth cores. You have all those cores in there at different time interval for you to sample or for you to harvest. So you will always make sure that these are taken up at different timing. For example, after 3 months, after 6 months, different samples. So you don't disturb them over time. So you are controlling the disturbance at some point. These are the sort of the gaps that we try to control it, rather than, over time you take a sample from one point itself, and then it just keeps deteriorating and doesn't give you a consistent sort of numbers, if you may. That's one burning question for Dr. Jayani. Thank you very much, Mr. Posun, for that. I think that clarifies a lot on those who have a little bit of inquiries or different needs, more understanding on fine roots. I want to go back to one more question. Let's go into, well, basically we have another 15 minutes. I want to work on towards our discussion for overall sort of presentation today. We have Dr. Tep talking about his dry dipterocarp forest, and Nizam talking about his decomposition, sharing his decomposition work, litters, fine roots, and of course, Dr. Jayani, who just gave an gave her talk on her work with regards to fine roots decomposition, and also how they collaborated and how they worked together in terms of this IFS sort of collaboration research grant. Any questions, please put it up on the chat box. And also, I would like to take 1 or 2 questions. We want to do it differently. So hopefully that we get some interaction this time rather than just having chat box and I pick it up from the chat box. So 1 or 2 person within the time frame that we have, another 10 minutes, if you can raise your hand and turn on your microphone, we will pick up 1 or 2 questions from participants. I want to bring up the questions where someone from April were asking perhaps Dr. Tep or Mr. Nizam about the explanation about NPP calculation. If there is any further explanation on NPP calculation, the method of measurement, above ground biomass, litter fall, and fine roots. I believe you presented this in terms of slides, in terms of photos and images. Do you have anything you want to add to these questions, to this comment?
Yes. I would like to share and add to the question again. I will prepare some answer to talk with you. The concept of my study in EP in this project, normally I think Dr. Ko said the description and the methodology for the finding the NEP in the world is quite concept is similar for carbon stock minus carbon emission. But in our team, I would like to focus on use in this concept, and we add some part of the fine root production. I think not too much for explain and finding the NEP by using this formula. And the methodology for study of delta M is above ground biomass, above ground living biomass increment, and causal root increment. We use the arithmetic equation in different type of the forest depend on in your country, I mean that in Thailand and in Malaysia, depend on the type of the forest. And the leaf fall, we use the above ground little tap, okay, at least 20 sample per each study. And the fine root production I used followed by Osawa in this formula. I think Dr. Jenny talked with the fine root production. Okay, and I would like to show some result for finding of the NEP and net ecosystem production in 3 different forests. I think I showed that in the conclusion of the NEP, but we find the delta M or above ground biomass increment, causal root increment. We have studied in 2 years, and we would like to know the NPP increment followed by this table. And litter fall, we collect the litter fall from the litter tab around 1 year. Fine root production, okay, followed by the Dr. Jenny talk, and this combine above ground, causal, litter fall, and fine root is the NEP or total carbon stock increment. For example, in Jenga and we observe the microbial respiration by using trenching method during a year. For finding the net ecosystem production, we've used, I show the formula already, NPP minus RM, or microbial respiration, or something like that. And this one is shown in the Paso Forest Reserve, something in the same methodology in our in different side in my country in Thailand. But okay, the net ecosystem production in Thailand is too higher than in Malaysia, because in our side is a secondary forest and growing the plant around 6 months, around 10 years ago. The plant is very fast to grow, and I would like to the mark point the very important compare between the natural or primary forest and secondary forest. You can see that the carbon stock in above ground and below ground biomass in the primary forest is higher than secondary forest. For example, in Jangga around 100, and in Paso around 140 ton carbon per hectare. But in our side in Thailand, it's too small, around 70 ton carbon per hectare or something. I think we need to focus on the carbon stock in the pen or something like that. In the primary forest, so too higher than in the secondary forest. But normally in the small pen, I mean the younger pen is very high growth more than the older forest.
Thank you very much for the explanation. I think it explains very well the questions that was asked. I want to bring back to one more question. I think it was quite lengthy. This is regarding by Jiseng Ong, if I'm not mistaken. This is to everyone. Is there any studies, mainly NEP, on urban forestry? If this is significant or this is not significant, and also if they can be, and if the NEP can be tied to carbon emission or green policies and carbon economy. And he also asked the last question, if NEP study on agricultural lands and how this can be contributed to sustainability. I want to answer question number 5 because this is related to me somehow. Yes, there are quite a number of studies on agricultural lands now, for example, rubber, oil palm, and these are very much related to the sustainability or sustainable development goal. And this is quite important for agricultural commodities, crops, for example. So any of the panelists would like to respond to urban forestry? Before we finish it up, we have another few more minutes to go.
So Dr. Ko, maybe I can reply for the urban forestry part. Maybe the rest who want to join in, who has some experience on that. I think I also saw that one of the participants, maybe Dr. Eric Velasco, shared a paper on NEP studies. I think in Malaysia, the values for NEP in urban forestry is still scarce. We don't have much work which has been done in a big portion. However, we also have to take into account that this urban forestry does go through some management, such as pruning and weeding, and all that may or may not also affect the NEP production of that particular urban forest. So based on the management that is being done there, it is very important that anyone who wants to devise work on urban forestry carefully look at how they can actually do the sampling without causing or producing any errors. So that's my take on that, Dr. Ko.
Thank you. Thank you so much on that. Anyone who wants to summarize this question on urban forestry. If not, there is a quick question, just maybe last one. I want to pick it up for Dr. Pomtep to discuss a little bit regarding uncertainties in your measurements and estimates. I'm sure this is very important to understand NEP. I'm sure it is important in our analysis and our values. What are the range, the uncertainties, errors involved? If you could quickly answer this in a minute or two. Thank you. Dr. Pomtep?
Yeah. Okay.
Yeah.
Okay. For the uncertainty of our study in different sites, I think it's very important point to find the uncertainty. But in this experiment, we are the setting for the use the same methodology for T site. I mean, include the in Vietnam also at 4 sites. For study the NEP, maybe for the next step, I would like to compare the result of the different sites and finding the uncertainty. Okay, thank you so much.
Thank you. Thank you so much. I'm sure this is really important, and I'm sure that when you work on towards your paper, I think this will be some of the things that we really need to look into in terms of the variation, the errors, and the range itself, and how do we compare to different forest types in terms of your decomposition and some of the measurements that you are conducting. So I want to briefly say sorry to the last question that perhaps was asking about the forest fire in Pitson Forest that can obviously contributes to air pollution and high emission of CO2. Perhaps that will be in another sort of webinar that we will be hosting if the other if our organization will be going towards that Pitson Forest. I would love to answer that question, but I think time is not in our side at the moment. But this could be really interesting discussion in another sort of webinar, perhaps in the future. But before I close this, I would like to thank the 3 presenters for taking the time to present this today, this morning, for their experiences, for their research that they have conducted over time for all these times, and for their collaboration. And also I would like to thank everyone joining this webinar this morning. We have about, I saw earlier, we have about 150, but now it slowly trickled down to 129. This is a good number as well. We thank everyone for taking their time to be involved and also to ask questions. And I think this is really good and productive for us to move ahead, especially for researchers and for students, for example, for them to move on in their research and future endeavors. And for my closing remarks, I would like to thank the organizers. I would like to acknowledge the organizers. Thank you to Forest Research Institute of Malaysia. And I would also like to thank Srinakarin Wirot University, Thailand. I'm sure I made it right this time. Malaysian Society of Soil Science, thank you for all your support, and thank you for all your contributions and collaboration with the researchers, with the presenters, with everyone today who are somehow related to these organizations. And I also like to thank the International Foundation of Science for the research grant, for this to happen, for the research to be conducted. And I'm sure, thank you all for the support, and I'm sure we will see each other again, and I'm sure the cooperation will continue in the near future. Thank you so much, and I hand it back to Ms. Satira. Thank you.
So just before Ms. Atira takes and closes the session, Dr. Koh, I would just like to thank you from the panel of speakers. Thank you, Dr. Koh, for moderating the session today, for saying yes. So we are very grateful for your time as well as your insights on the presentations that we presented today. I hope that we meet again and we collaborate again in future on research subjects related to what is of interest of today's webinar. Thank you, and we pass it over to Ms. Atira to close the session.
Okay, everyone, thank you so much for joining. Special thank you to Dr. Koh, Dr. Jayani, Mr. Nizam, Dr. Tab for conducting this webinar today. So for all the participants, if you have any question, you can email me at the email that I attached at the chat. It's atirakarim12@gmail.com. So please, you can leave me a message if you have any question or any problem. So I think we may end this discussion now. So we hope to see you soon and have a good day.
Thank you, Tira. Thank you, Dr. Koh.
Thank you,
Thanks.
Thank you,
everyone.
Tab.
Thanks,
Okay,
everyone.
Thank you,
Thank you,
everyone.
Dr. Jay. Thank you.
Bye-bye and stay
Bye.
safe. Yeah.
Bye bye. Yeah.